Today, we're diving into something huge, an idea that could completely flip our entire understanding of how the universe begins and how it ends. So let's just jump right in.
You know, everything we're about to talk about really just boils down to this one single question. What if the most famous explosion in history wasn't an explosion at all? What if it wasn't even a beginning?
Okay, so to really get our heads around this new idea, we've got to take a quick look at the standard story of our cosmos. A story that, has a very clear beginning and a potentially pretty destructive end. So on one hand, you've got the Big Bang, right? The ultimate cosmic start. And on the other, you've got black holes, the ultimate cosmic end. Now, we usually think of them as total opposites. One creates everything, the other crushes it. But here's the thing. They both lead our best theories to the exact same, really uncomfortable problem.
And that problem is called a singularity. Now, a singularity isn't necessarily a real thing. It's more like a giant stop sign for physics. It's the point where our math just breaks. It tells us we've hit a wall in our understanding. And both the Big Bang and black holes lead us to this exact same dead end.
So what if that dead end isn't a dead end at all? What if we've just been looking at the whole picture upside down? This is where this whole new framework comes into play.
And here it is. This is the central idea, the light bulb moment from the source material. It just reframes everything. Instead of a separate beginning and a separate end, what if we're just seeing two parts of a single, continuous cosmic process?
So how would a process like that even work? Well, it's actually a beautifully simple three-step flow. First, you get compression. Just think of a black hole squeezing matter down to its absolute limit. But, and this is the key, instead of just ending there, it hits a point of transition. And out of that transition, you get step 3, release, an expansion that looks an awful lot like our Big Bang.
Okay, this new model is elegant for sure, but does it actually explain what we see in the universe? Well, it turns out it offers a really fascinating answer to one of cosmology's biggest puzzles. Why is the universe still expanding?
This table really gets to the heart of the different ways of thinking. The standard model says our universe is coasting. It's kind of like a car that's run out of gas and is just rolling on that leftover momentum from the initial explosion. But in this new model, the universe is actively unfolding. The expansion isn't leftover energy. It's an ongoing process of decompressing. Think about it like a tightly coiled spring that's just been let go. The expansion is still happening because the system hasn't reached its final relaxed state yet. It's still in the process of unfolding. So the bang isn't some event in the distant past. In a way, it's still happening right now. Now, an idea this big has some pretty deep implications, not just for black holes, but for the very nature of time and space itself. And it brings up a very big question that I am sure you're already asking. Let's just put it right out there, because this is where everyone's mind goes first, right? If our universe is the result of a black hole's collapse, does that mean we're all living inside one right now? The answer, according to this theory, is an emphatic no. And the reason why is actually incredibly important for understanding this whole model. See, the black hole isn't a container that we're trapped in, it's the cause that came before us. Think of it like a seed for a tree. The seed is causally prior. It sets up all the initial conditions. But the tree isn't inside the seed. The black hole basically provided the starting conditions for our universe, but it's not our cosmic home. And besides, everything we see shows the universe expanding uniformly in all directions, which is the exact opposite of what you'd see inside a black hole.
And this model even gives us this really profound insight into time itself. In this view, time isn't fundamental. It's something that emerges from the process. The arrow of time that we all experience, moving from past to future, is simply the universe moving along a gradient, from that state of maximum compression toward a state of complete irreversible release. So let's pull all of this together now and explore what it means for the big picture, a cosmos that might not have absolute beginnings or absolute ends. This forces us to completely rethink what a black hole is. It's no longer a cosmic dead end that just gobbles up information and destroys everything. Instead, it becomes a point of transition, a gateway that reorganizes matter and energy and sets the stage for a whole new cosmic process to begin on the other side.
And that leaves us with some truly massive, mind-bending implications. It could mean that singularities aren't actually real things. It could mean our universe isn't a one-off event, but maybe just one part of an endless cycle. And it means that black holes aren't the end of the story. They might just be the starts of the next chapter. And all of this brings us back to one final, really powerful idea that just captures this entire perspective. By changing how we look at the problem, we get to a pretty startling new conclusion. The universe may not have begun with a bang, but with a release.